Q4238. Hazardous wind shear is commonly encountered near the ground. A. During periods when the wind velocity is stronger than 35 knots. B. During periods when the wind velocity is stronger than 35 knots and near mountain valleys. C. During periods of strong temperature inversion and near thunderstorms. The correct answer is C. Hazardous wind shear can commonly be encountered near the ground during periods of strong temperature inversion and near thunderstorms. 4135. Where can wind shear associated with a thunderstorm be found? Choose the most complete answer. A. In front of the thunderstorm cell, anvil side, and on the right side of the cell. B. In front of the thunderstorm cell and directly under the cell. C. On all sides of the thunderstorm cell and directly under the cell. The correct answer is C. Wind shear associated with a thunderstorm can be found on all sides of the thunderstorm cell and directly under the cell. Thunderstorms are dynamic and complex atmospheric systems that generate significant vertical and horizontal air motions. These air motions can lead to variations in wind direction and wind speed, resulting in wind shear. 4720. When passing through an abrupt wind shear which involves a shift from a tailwind to a headwind, what power management would normally be required to maintain a constant indicated airspeed and ILS glide slope? A. Higher than normal power initially, followed by a further increase as the wind shear is encountered, then a decrease. B. Lower than normal power initially, followed by a further decrease as the wind shear is encountered, then an increase. C. Higher than normal power initially, followed by a decrease as the shear is encountered, then an increase. The correct answer is B. When on an approach in a tailwind condition that shears into a calm wind or headwind, at first the IAS and pitch with increment, and the airship will swell over the float slope. Control ought to begin with be decreased to adjust in condition. Control should be assist decreased as the airplane continues through the wind shear, at that point expanded. 4727. While flying 3 degrees glide slope, a constant tailwind shears to a calm wind. Which conditions should the pilot expect? A. Airspeed and pitch attitude decrease, and there is a tendency to go below glide slope. B. Airspeed and pitch attitude increase, and there is a tendency to go below glide slope. C. Airspeed and pitch attitude increase, and there is a tendency to go above glide slope. The correct answer is C. When an aircraft that is flying with a tailwind suddenly encounters calm air, it is the same as encountering a headwind. Initially, the IAS and pitch will increase, and the aircraft will balloon above the glide slope. 4739. Thrust is managed to maintain IAS, and glide slope is being flown. What characteristics should be observed when a headwind shears to be a constant tailwind? A. Pitch attitude increases, required thrust increased, then reduced, vertical speed increases, IAS increases, then decreases to approach speed. B. Pitch attitude decreases, required thrust increased, then reduced, vertical speed increases, IAS decreases, then increases to approach speed. C. Pitch attitude increases, required thrust reduced, then increased, vertical speed decreases, IAS decreases, then increases to approach speed. The correct answer is B. When a headwind shears to become a constant tailwind while maintaining indicated airspeed, IAS, and flying the glide slope, the following characteristics should be observed. Pitch attitude decreases. As the headwind shears to a tailwind, the relative wind direction changes, resulting in a decrease in the effective headwind component. To maintain the same indicated airspeed, the pilot needs to reduce the pitch attitude, which lowers the nose of the aircraft. Required thrust increased, then reduced. Initially, as the headwind shears to a tailwind, the reduction in headwind component reduces the aerodynamic forces acting on the aircraft. To counteract the decrease in lift and maintain the glide slope, the pilot needs to increase the required thrust. However, as the aircraft adjusts to the new wind conditions and the tailwind stabilizes, the required thrust can be reduced. Vertical speed increases with the reduction in headwind component and the need to maintain the same indicated airspeed. The aircraft's vertical speed will increase. The decrease in effective headwind reduces the opposing force, allowing the aircraft to descend at a higher rate. IAS decreases, then increases to approach speed. Initially, as the headwind shears to a tailwind, the decrease in headwind component causes a reduction in indicated airspeed. This decrease in airspeed occurs as the aircraft transitions from the headwind to a tailwind. However, as the pilot adjusts the required thrust and pitch attitude, the indicated airspeed will eventually increase back to the approach speed.